things, a couple quizzes, yeah? Exponential modeling, if you want to do it, and an exponential review quiz, which I threw up just in case you want to kind of get your feet wet with that again. Please, Michelle.
I had a question about one of those quizzes. How do you solve for x?
We'll come back to that.
Okay.
And we can talk more at the break if you need it, but I knew that question would come up. It's come up a couple times already. Francis?
I just had a quick question. This is totally random, but when I was putting my shoes on, I was thinking the gold standard is the reason why we have certain size of shoes.
The old standard.
The golden standard.
What's the golden?
ratio.
Oh, the feet. Is that our feet too? Is that why it's called feet? Is there a
Is that
feet?
why we have size 6 or size 7? Is it because of the golden ratio?
I don't think my foot's golden ratio. Mine are pretty ugly feet, but
I mean, we have like size 6 or size 7.
I would imagine, have you ever seen, it's going to sound like a tangent, but there's a great email my mom sent me that said, can you believe that the most sophisticated piece of technology the world has ever seen, and this is a bit of it was the space shuttle. The size of the space shuttle is entirely determined by the size of a horse's ass. Has anybody ever seen this email like this one? What they did was, it's related to your question, Francis. It was the idea that when they built the space shuttle, the space shuttle is not in use anymore, but it was for many, many years. And they had to move the space shuttle from where they built it to where it launched. How do they move it? On a train, believe it or not. I thought they would take it on like roads, but apparently they took it on trains. Train track. Now, train track, that means they have to build it so the pieces of it could be broken down to pieces that would fit on a train car. So, in other words, we have to build the space shuttle, which is this huge thing, to break down like Legos into pieces that are no bigger than what would fit on a train car. So, how big is a train car? And they method the measurements of a train car. Why is a train car the size it is? And this is, I started thinking, I'm like, I have no idea. Like you used to, I mean, I was in college, we used to ride trains all the time, and we looked down at the tracks and like, you know, like we just walk along them, you know. We never think about why is it like, you know, this wide. And as it turns out, there's all these historical tiebacks, and the furthest they can tie it back is Roman chariots. They're based roughly on the size of a Roman chariot. And the Roman chariot is roughly designed to fit 2 horses' asses in front of it. So they said it's arguably the most sophisticated piece of technology in the world is the way it is because of the size of a horse's ass. Isn't that amazing? So I would imagine that our shoe sizes are tied back to somebody's regal foot. That's why it's probably called a foot, is because some king somewhere's foot.
Clothes size or whatever.
Oh yeah. Now that ratio, that phi ratio, is actually in your toes, arguably. There's all kinds of places. I was talking to somebody about this, I forget who it was. But if you measure like the successive bones in your feet, your hands, and your phalanges, and whatever your feet phalanges are, there's like golden ratios built into that. And people then wonder, okay, like why does it show up so many places? And I think it's because we're looking really hard. It's called confirmation bias. Oh. When you constantly say things like, oh, I found it again, oh, I found it again. Yes, but I'm not finding it right now. Like those lights, that's not the golden ratio. Those ceiling tiles, that's not the golden ratio. That board behind Microsplash mat, that's not the golden ratio. Right? I mean, there's plenty of, the tiles you're standing on, that's not the golden ratio. Like the thing about, it's very easy to find coincidences in your life if you ignore all the ones that don't fit what you're looking for.
Right.
So that's, I guess, part of it. And this is what 243 kind of picks up too, is the idea of measuring probability by looking at the entire, what's called a sample space, which we'll get into next week. That's what we'll get into next week. Good?
Woo, yeah.
That's a lot.
Yeah,
it's a lot. It's interesting how math reaches back into history like that. I mean, if you get a chance, Google that whole space shuttle horse's ass, and you'll find it. It's a great little historical thing. It really is. It's fun. It's fun. Yeah. Thank you for this. So quizzes this week: exponential modeling and exponential review. That question, Michelle, I guarantee will come up at some point today. Don't forget equation boot camp. That's the best thing I can tell you. You can solve any equation using the methods in equation boot camp. We'll actually probably see it today, and you'll understand why it works. All right. Speaking of exponential modeling. Let's get back into the data. We had 2 data sets last time. And the 2 data sets we had were coin flips and cards. And I used coin flips, I think it was until we got heads, wasn't it?
Yes.
Yeah, I remember that. And then it was card deals until, thank you. Until, let's make it red, why don't we? Until diamond. And I know we ignored that data because we were so buried in this data here, and I want to finish up with the coin flip before we go over to the card data as well. So I still have